the baseball and softball field soil test analysis. Today I'm going to talk to you about our soil on our baseball field. There has been many conversations about how we can improve our field. Flooding is one of the biggest problems within our fields. What does flooding do to our field? When a flood happens, there becomes less oxygen available to our plants. Now I know we don't grow anything but grass on our field, but low oxygen affects the grass being able to grow as well. Then you have a bare ground and water that stays on the surface for way too long. When all the water is gone, then you have a very dry field. There is no in between. Not only does flooding decrease oxygen, but it also causes leaching of important nutrients of the soil that we need. This is when you need to add in more nutrients. Since our field does it frequently, we need to have steady nutrients being put back into it. Soil pH. If we look at the pH in the soil, which is the measurement of acidity or alkalinity of the soil. The difference between the two is acidity is when the water's ability to neutralize a base, and alkalinity is when the water's ability to neutralize that acid. So our soil pH in the baseball field is 6.3. There is a range between 6.1 and 7.0, which is classified as slightly acidic. Is that good or bad? Anywhere from 6.5 to 8.5 is considered good. We are below that range of numbers, meaning our soil needs some improvement in our pH. Phosphorus, potassium, and zinc. When we talk about soils, we often hear N, P, and K. That is referring to nitrogen, phosphorus, and potassium. On the results we were given, it talks about P, K, and zinc. Phosphorus. We had 60 ppms, means above optimal or high. So our baseball field is doing really well in phosphorus. However, too much can cause problems as well. When there's too much phosphorus, it can potentially reduce the ability to take up the required amount of micronutrients, mainly iron and zinc. Phosphorus is a macronutrient. A macronutrient is the carbohydrates, fats, and proteins within a soil. Potassium, we had about 154 ppms, which is optimal, which is the ideal range you want to see. Our field is good with potassium that it has within it. Potassium is also a macronutrient. Zinc, we had 5.9 ppms, which is ideal, the right amount we want to see, not too low or high, and just a little bit more than medium. Our softball field's phosphorus was 18 ppm. This is a low number and in the range 16 to 25, which means it's low and it needs to be brought up. Low macronutrients can cause low or no production. That is why we're seeing no grass being in our fields. We typically see little grass, which means we have low macronutrients and we need to put more in there. There was 119 ppms in potassium, which falls in the 91 to about 130 range. This is medium. Medium is not something to complain about for sure, but we also need to add some more macronutrients in it and have a higher number. So 119 is one that isn't terrible to see. Zinc, we had 4.7 ppms. That falls in the optimal range as well, just like the baseball field had. This is an ideal number. You have to watch the zinc numbers close. This is because if you have too much zinc, it can cause stunt growth problems, which is what we're seeing. The main problem we see in our fields today about fixing them is money. I have looked into some different options for our baseball fields and softball fields. Turf grass options can run anywhere from $2.10 per square feet. If we do 48,560 square foot, which is 1 acre, which is what our paper had, then we would times that by $2.10, and that would be about 101,976. Bermuda grass, ryegrass, and bluegrass are all turf grasses that can grow in Arkansas. We would typically start by getting a soil test, and we already have one, so we already know what we're lacking. Turf grass would be the best thing we could do for our softball and baseball fields, but it's the worst option when it comes to money because we don't have a lot of it. Fertilizers for the field would be about $20 to $35 per bag, which is a 50-pound bag. If we are going off of those numbers with the 1 acre, we can put $20 per bag, and that comes out to about $97,000. If we went with the organic fertilizer, we would run about $50 for 8,000 square foot. If we do that math, then it's about $300 for 6 bags, which is about what we need. Rough estimate there. But those are all things that we can do to improve our softball and baseball fields. That concludes my presentation.